So now this last problem, example 6, kind of just ties everything all together. So it says, let the random variable x represent the number of girls in a family of 3 children. Construct a table describing the probability distribution, then find the mean standard deviation. Is 3 girls a significantly high number of girls for a family of 3 children? So the first thing we need to do is we actually have to describe our random variable and our probabilities. So in this case, since we're talking about the number of girls in with a family of 3 children, then what could that possibly be? So well, you could have 0 girls, you could have 1 girl, you could have 2 girls, or 3. So that would be your only possibilities for your random variable x. Now for your p of x, now comes the fun part. We actually have to create a tree diagram. Yay. So the first child, your second child, and your third. So we got boy and girl, which ties off to boy and girl on both of those. And one more time. So that helps you get your sample space, but now we actually have to describe all those different outcomes. So we got boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. Okay, so now we've got our sample space. We have all of our unique outcomes, so they're all simple events, to go back to the terminology from before. And so now, what's the probability of getting 0 girls? And there's only 1. 1 out of all 8. So 1 out of 8, which is 0.125. Okay, so now 1 girl. So we got 1 case here, 1 case there, 1 case there, and that's it. So 3 out of 8, which is 0.375. And then we got 2 girls. So 2 girls, we got 1, 2, 3. 3 out of 8 again. So 0.375, and then there's only 1 case with all girls, so 1 out of 8, so 0.125. So that gives us our probability distribution, but now we just got to fill in the rest of this to get our mean, excuse me, and standard deviation. So if we multiply across, it's going to be the easiest. So we got zeros there, 0.375, 1, 0.375, 0.75, oops, excuse me, little boo-boo there. So 2 times that, oh no, I was right. So 0.750, 4, so this will be 1.500. And then we got 0.375, 9, and then we got 9 times that, so 1.125. So that fills in the table, and so now if we want our mean, remember the mean is just the sum of x times p of x. So if we add all of that up, looks like we get 1.5 girls. And then our standard deviation, so we have to add this up, and this looks like 3. So we got 3 minus 1.5 squared, so 3 minus 2.25, which is the square root of 0.75, which is 0.866 and change. So now, if we wanted to be easy, we could round it to the same number of decimal places as our mean. So they only have 1 decimal point. So if we wanted to round this to 0.9, just to be easy. So 1.9 girls. Okay, so now we got our mean and standard deviation. So now we gotta look at significance. So because we got mean and standard deviation, significance is most easily done using the range rule of thumb. So that's our min and max significant values. So if we get our min first, our min would be our mean minus 2 standard deviations. So that's going to be a negative 0.3 girls. And then our max should be, oops, 1.8, that looks like 3.3. So there should be our cutoffs for min and max usual values. So now the question wants to know, is 3 girls significantly high number of girls? Well, so again, you've got to compare that to these cutoffs. So 3 is between these two, and when it's between, that means it's not significant. So 3 girls is not significant because, and you can just use the inequality format. So that's one way we could have done it. But technically we can do it the other way, remember, if we look at the probabilities. So if they want to know if 3 is significantly high, remember you want to look at 3 and above, the probability of 3 and above. Well, there's nothing above 3, so all you're really looking at is the probability of 3. So you could have also said, no. And the reason why is, look at the probability. Remember, if probability of 3 and above is less than 5%, then that means it is significant. But if it's greater, then it's not. So no, because 0.125 is greater than 5%. So you got both ways to describe that probability or that occurrence being not being significant. So, all right, so that wraps up that section. So now you can go into 5.2 and kick butt there. See you in the next video.